Hello everyone and welcome to my channel MiTutorials. This is our first session of our beginner's guide to DAX in Power BI. If you've ever felt overwhelmed by DAX formulas or unsure where to start, don't worry, you're in the right place. Today, we'll simplify the world of DAX and walk you through the most essential functions every beginner needs to know. By the end of this course, you'll be confidently writing your first DAX formulas. So grab your coffee, open up Power BI and let's dive in. So I'm going to explain the concept of DAX in a very simple language so that you guys can understand and follow along. I will also be showing you a lot of practical examples so that you can follow along and implement this at your workplace. So let's get started. Let's understand what is DAX. DAX stands for Data Analysis Expressions. It's basically expression language used in various platforms, not just in Power BI. You can use DAX in analysis services, in Power Pivot, in Excel, as well as in Power BI. DAX formulas include functions, operators, and values to perform advanced calculations and queries on the dataset. With DAX, you can create powerful measures for dynamic calculations. You can build complex aggregations like your year-to-date totals, year-over-year, quarter-over-quarter, etc. You can handle conditional logic seamlessly. Now let's take a look at the simple DAX formula and understand how exactly it looks like. For example, this is the DAX formula that I have here. The first section of the DAX formula here that I have is basically the name of our measure, which is total sales, followed by a function here, which is the sum function. We saw that DAX formula includes functions, operators, and values. So the sum function here is basically a function used to aggregate the field that we have here, which is the sales amount. So when we use the sum function, we are basically asking DAX to sum the sales amount column. So let's jump into Power BI and recreate this particular measure that we just saw. I'm now here in Power BI. I have a table here basically called sales, and I have a quantity column here. Let's try to sum the quantity column here. Let's understand what is the total quantity of sales that we have in our data set. So let's come down over here in my sales table. I'm going to click on these three ellipses here. You can click on new measure, or you can head to the modeling tab and then click on new measure. You can either do both of them. So when you click on new measure, the first section, like we discussed earlier, is our measure name. Let's call this as total underscore quantity is equals to, followed by the sum function. So this is our sum function. And then pass in our quantity column that we have in our data set. When you just type in QUA, it will try to autofill the column that you have in your data set. Simply click on tab and then it will be autofilled, and then click on close and then click on confirm. And now we have our total quantity created. If you simply bring this measure into our report page and change this into a card, you will now see that our total quantity that we have in our data set is 198K. So that was the simple total sales or total quantity measure that we just created. Now let's head over to the next section, which is understanding the difference between a measure and a calculated column. DAX is used in both creating a measure as well as a calculated column. By definition, measure is basically a dynamic calculation performed on the fly based on the filter context in a particular visual. Now, I'm going to explain what filter context means in detail, but for now, just understand that measure works based on a filter context in a particular visual, whereas a calculated column is a static calculation that creates a new column in a table. It physically creates a new column in a table, which is calculated row by row. Now let's take a look at the practical example of the calculated column as well as a measure. Let's head over to Power BI. In my table view that I have here, I have the quantity column and I have the price column. Now let's say if I want to multiply my quantity column with the price column, I can add a calculated column. So I can simply go to my column tools and then click on new column, or you can simply right click here and choose new column. Once you do that, you will have to give it a column name. In this case, I'm going to call this as total price and say is equals to. I can now directly refer to the column that I have in my table. In this case, let's say if I want to multiply my sales quantity with the price, when I type in price here, it will give me suggestions that are available to use. This is the column that we want to refer to. And when I click on confirm, it is now getting calculated row by row. For every single row, the DAX is performing the calculation. It is multiplying the quantity with the price and it is displaying the output here. Just like how you multiply in Excel you refer to a particular cell, but in DAX you refer to a particular column and the calculation happens row by row. And you can see that the calculation has happened in the entire row here. You don't really have to drag the formula like you do in Excel. In this case, it happens automatically, and that is why it is said that the calculations happens row by row, and we can see a physical column saved in our table. Now let's create a measure and see what happens. So when I click on these ellipses here and click on new measure, I can give it a measure name. Let's call this as total price underscore measure. And let's say is equals to, and then now I want to refer to my price column. When I type in price here, you can see that it is no longer giving us the option to select the column directly, right? I cannot multiply or refer to a particular column in a measure because the measure is calculated based on the filter context, not calculated row by row. So if I have to now multiply my quantity with price, what I need to do is I will have to use a function here called SUMX, and then pass in the first argument here is the table. So I'm going to pass in my sales table here followed by a comma, and then I can now pass in my quantity column, multiply that with the price column, sales price, close the bracket and confirm, and you will see that we have not created a column in our table. It is only a dynamic measure which is available. I'm going to explain this function in detail in the later part of the video when we discuss about functions. But for now, just to help you understand the difference between measure and calculated column, I have created this. And when I bring this total price measure into a card, let me change this to a card. You can see that this is the total price that we have in our table. And let me bring in a slicer here. I've added a slicer here which has the year column just to filter the data. And when I click on this, you can see that our measure is also getting filtered and it is displaying the data only for the year 2019. When I change this, the value changes. The measure is now getting filtered to display the sales data only for the year 2017. Now this is what the filter context means. When I change this into a table, and if I bring in, let's say, currency code, or if I bring in, let's say, category into the table, you will see that we've now added a filter context into our table. All of these categories that you see is basically acting as a filter in our visual, and our measure is getting calculated based on the filter that we have applied into our table. So when I said based on the filter context, a measure is performed dynamically based on the filter context in the visual, this is exactly what I meant. Now all these here are filters which are basically being applied to our measure, and that is being calculated on the fly dynamically. So just to help you understand and recap, a measure is basically a dynamic calculation performed on the fly based on the filter context, whereas a calculated column is creating a new column in our table which is calculated row by row. I hope the difference between the measure and calculated column definition is now clear. Let's take a look at the next criteria that we have here, which is the calculation context. The calculation context here, when it comes to the measure, is calculated at the visualization level. Now, if you do not add this particular measure in any of these visuals, it means that the measure is just sitting here. It is not getting calculated unless and until you bring in that measure into any of the visuals. Now I have the total quantity measure that we created earlier, but I have not added that into our visual, which means that the total quantity measure is just going to stay there. It is not going to get calculated unless and until I bring in my total quantity into our visual like this. Only when I bring in my total quantity into our visual, the calculation is happening. Otherwise, the calculation does not happen. But on the other hand, the calculated column in here, whether you bring this into your report view or not, the calculation happens in the backend and it is stored as a column in our table view. right? The calculation context here, just to understand again, calculated at the visualization level depends on the applied filters or slicers, whereas a calculated column is calculated at the row level once the data is loaded or refreshed. When the data is loaded, the calculation happens every single time, or whenever I refresh my data set, when I come here and click on refresh, the calculation happens once again in this particular table. Now, once the calculation is done, it is not going to recalculate it again unless and until I reload my data or refresh my data. Whereas the measure gets calculated every single time whenever you bring this particular measure into this visual. Now let's come to the next criteria here regarding the storage. Like I mentioned earlier as well, results are not stored. It is calculated dynamically only when required. Whenever you bring in the measure into your visual, the results are calculated. Until then, the results are not calculated. But on the other hand, the calculated column results are pre-computed and stored in the data model. Now coming to the performance between the measure and the calculated column, the measures are more efficient as they are calculated only when needed. Whereas the calculated columns can impact your performance if there are too many calculated columns in your data model. So when can you use a measure and when can you use a calculated column? The use cases where you can use a measure in aggregations, like when you want to calculate sum, average, you want to rank, etc., or depending on the filter context. On the other hand, the calculated columns can be used to identify maybe buckets, or you want to do some sort of categorization, or you would like to create a profit margin or sales margin, etc. Let's take a look at the syntax example. Total sales is equals to sum, the function that we have used here, and it is referring to a column, whereas a calculated column can simply refer to two different columns and perform calculation. So that is the quick difference between a measure and a calculated column. Now let's head to the next section where we will learn some of the basic aggregation functions. These are some of the commonly used aggregation functions in DAX. So let us see how we can use them. Let's start by the sum. I'm going to create a new measure. Let's give it a name. I'm going to call this as total quantity is equals to, followed by sum, which is our function. Now, when you create a sum function, it basically sums the value in a particular column. You will have to pass in the column name. Whenever you enter a function, it will automatically give you a pop-up of what the argument is. For example, in the sum function, you will have to pass in a column name. Now the column name here, whenever you're using the function sum, always has to be of data type number. You cannot have a text as a data type and try to sum that. What happens when you do that? For example, if I want to sum the gender here, close the bracket and confirm. When you bring in the measure into your report, you will see that there is an error here. When you click on see details, it says that the sum function cannot work with values of type string. So when I want to sum the quantity here, I will pass in the quantity column, close the bracket and confirm. And now you can see that we are displaying the total quantity that we have in our data set. Now let's head to the next function here. I'm going to create a new measure. Let's identify the average quantity that we have in our data set. So I'm going to type in average underscore quantity is equals to, and I can now pass in the function average. I'm going to open bracket and you can see the argument here which says column name. I'm going to pass in the column name here, which is quantity, close the bracket and confirm. And if I bring in the average quantity here into a new card, you will see that I have my average quantity here, which is 3.14. 3.14 is the average quantity that I have in my data set. Now let's say you want to count a particular column. Let's see how we can do that. I'm going to click on these ellipses and then do a count underscore store is equals to. I can now use the count function here. When I use the count function, again I can pass in my column name. The column name that I want to pass in here is the store key. I want to count the number of store keys here, close the bracket and confirm. And when I bring in the count store here into a card, you will see that I have 50,000 stores here. Let's quickly change this to none so that I see the absolute values. I have 49,719 store keys in my data set. Now, this is the number of stores that I have. I can create another measure in case if I want to identify the unique number of stores that I have in my table. So to do that, let's give it a name. I'm going to call this as unique store count is equals to, this time I'm going to use the function here called distinct count. When I use the function distinct count, I can pass in my column name here, which is the store key, close the bracket, confirm, and when I bring this into a card, you will see that I now have my unique count of store keys, which is 58. Now let's learn the next function here, which is, let's do count underscore rows is equals to, I want to count the number of rows that I have in my data set. So I'm going to use the count rows function. I have the count rows function here. I can now pass in the table itself. Whenever you use a function, you will have a pop-up like this. It will tell you whether you have to pass in a table name or you have to pass in a column name, right? In this case, when I use the count rows function, it is asking me to pass in the table name. When I pass in my table here, close the bracket and confirm, I can now display the number of rows that I have in my table. And if I change this into absolute values, you can see that I have 62,884 rows. And when I did a count here on the store column, you saw that my result set was 49,719. Whereas when I'm doing the count rows, I have 62,000 rows, which means that I do have some blank rows in my store column. So let's take a look at that. I'm going to create a new measure now to identify the blank stores. Let's call this as blank stores is equals to, I can now use the function here called count blank and then pass in the store key that I have, close the brackets and confirm. And when I bring in the blank stores into our table and change this into a card and then change this to absolute values. And now you can see that I have 13,165 blank data in my store key column. So with this, we have finished some of the commonly used aggregation functions. We looked at sum, we looked at average, count, count rows, distinct count. We also took a look at count blanks as well. There are many other aggregation functions as well that you can explore at a later stage. But for now, knowing these aggregation functions to start off with is good. Let's head to our next section, which is the logical functions. The logical functions are basically used with a conditional logic. We have an if statement, we have a switch statement, and we have and or statements where you can combine multiple conditions. Let's take a look at an example of this. So let's take a look at the if function first. Now, should you create a measure or should you create a calculated column? Let's see what we can do here in this case. In my products table, I have a column here called brand. Now, I want to add a new column. Wherever the brand is litwear, I would want to classify that as a luxury brand, and I want to classify the rest of them as non-luxury brand. Now, let us see, can we do this in a measure? Let us see if we can do that. I'm going to click on these ellipses here and select, I'm going to click on these ellipses here and select new measure. And we can use the if statement. If is a function here, open bracket, and it will tell you to enter the logical test first as your first argument. Now the logical test will happen only when I refer to my brand column. Now when I type in brand here, you can see that it is not letting me, or it is not giving me any of the options to select the column directly because we are creating a measure. Earlier we learned that in a measure you cannot refer to a particular column because a measure works based on a filter context, not on the row context by default. So what can we do now? So instead of creating a measure, let us create a calculated column. So let us create a calculated column now. I'm going to click on new column. Let's give it a name. Let's just call this as type for now is equals to. I'm going to use the if statement. The first statement here is the logical test. When I create a calculated column now, I will now be able to refer to that particular column directly. So when I type in brand, you can see that I have the option here to select the brand, and now I can say if my brand is equals to, open double quotes and type in litwear, close the quotes followed by a comma. When you type in a comma here, it will automatically tell you that the next argument is now enabled. Result if true. If true, what is it that you want as an output? In my case, I will open the quotes, double quotes again. And if it is litwear, then I want to identify this as a luxury brand. Close the quotes here, followed by a comma. If this is false, if this is not a litwear, then I would like to identify this as non-luxury. Close the quotes, close the brackets, confirm. And now we have a column here called type, and that has two different values. One is luxury and the other is non-luxury. When you click on luxury and click on OK, you will see that we only have one brand here, which is litwear, and the others are all non-luxury brands. So this is how you'll be able to create a calculated column. Within the calculated column, this is how you will be able to use an if function, which will conditionally define what your output is going to be. Now let's take a look at another example of the if statement. In my customers table, I have a column called zip code, and you can see that in this particular column, I have some blank values. I would like to identify how many blank values do we have, or I want to add a new column just to tell that zip code is available and zip code is not available. So let's create a new column here. I'm going to create a new column and call this as zip underscore available is equals to, and when I type in my if condition here, the first thing that I have to define is the logical test. To identify the blank or null values, we have another function here called isBlank. Within the isBlank function, you will have to pass in the field or the column name. In this case, it is zip code. I'm going to pass in just that, close the bracket here, followed by a comma. If zip code is blank, what is it that you want as an output? I'm going to type in zip code. I'm going to type in not available. Close the quotes, followed by comma. If this is false, I'm going to type in available. I want the output as available. Close the bracket and confirm. And now you can see that wherever my zip code is blank, I'm getting the output here as not available. And wherever I have my zip code, I have this output returning as available. Now let's take a look at the next example, which is where we can combine multiple conditions. We will come back to switch after this. Now in my products table, I have a column here called unit cost USD and unit price USD. I want to identify all of those products which has cost of more than or equal to $300. But their unit price is more than $1,000. So let us see how we can do that using our if statement, because these are my high margin products. So to identify the high margin products, I will have to apply an AND condition here, which means that the condition has to meet in the unit cost column. The condition here is that it is going to be more than $300. And the unit price also needs to be more than $1,000, which means that this is an AND condition. Both of these conditions has to meet in this case. So let us see how we can do this. I'm going to create a new column, and let's call this column as high margin products is equals to, I'm going to use the if statement. Within the if function, I will pass in the AND function here because I want to apply an AND function to check the function, to check the condition in both of these columns. I will now pass in the cost field here. If my cost field is greater than or equals to 300, followed by a comma, I now have an option to enter my logical 2 here, which is our second condition. And in this case, I'm going to pass in my unit price USD. If my unit price is greater than equals to 1,000, I'm going to close the bracket here, which means that I'm closing the condition for the AND statement, followed by a comma. If these two conditions meet, what is it that I want as an output? I'm going to open double quotes here, type in yes. If this condition is met, then it needs to return a yes, else it needs to return a no. I'm going to close the quotes, close the bracket. Now our if statement is complete. I'm going to click on commit or confirm. You will see that we now have a new column here. When I click on this drop down, I have no, I have a yes as well. So let's take a look at the yes products here. I'm going to click on OK. And now you will see that I have my unit cost USD, which is greater than 300 here. And when I come into my unit price USD, you will see that this is greater than equals to $1,000. All of these products here are my high margin products. I have used an if and condition to check for multiple conditions and return a conditional output. Now let's create another column to identify all the fast moving colors. Let's say, for example, I want to highlight or I want to identify the colors which are black and red. I want to tag them as fast moving colors and the others as non-fast moving colors. So let us see how we can do that. Now let me create a new column. Call this as fast moving underscore colors is equals to. Now, if I use an AND statement here, just like how we did earlier, let us see what happens, right? Now, when I pass in the color column here, I'm using the AND statement. When I pass in the color here is equals to black, comma, and then color again is equals to red. Close the quotes, close the bracket. I have now closed the AND function followed by a comma, open quotes. If this is black and red, then yes, it's a fast moving color. Else it's a no. Close the quotes, close the brackets for if statement and then click on confirm. You will see that we've only returned a no in this case, but we do have black here, right? We do have black, we do have red, but why is this returning us only a no here? The reason why it is returning a no is because we are using an AND statement here. The AND statement basically means the product color needs to be black as well as red. Now, when you have situations like this, you will have to use a different statement. In this case, you will have to use an OR statement. When I change this to OR and click on confirm, instead of and, I'm using an OR statement here. And now you will see that I have an yes as well as a no. When I select yes here, you will see that I have the black and red colors here, which are categorized as fast moving colors, and the rest of them are categorized as non-fast moving colors. Now let's say, for example, you have another color here, let's say green, and you want to categorize that as well as a fast moving color. But when you come into the OR condition here, you type in a comma here because you want to add another color. You want to add the green color also as a fast moving color, but you do not have an option to add another condition. So what do you do in these scenarios? Let us see what you can do to handle such scenarios. Let's click on cancel. Let's add another column. This time I'm going to explain a new function to you. I'm going to use the switch statement, switch fast moving colors, right? Let's call this as switch fast moving colors. There is another statement here called switch, which basically is a conditional statement. Let us see how we can use this. So the switch statement here, this is the switch function. Within the switch function, you will have to enter the expression, value, result one, else, etc. So these are all the arguments that you can pass in within a switch. So in the switch statement, I'm going to first pass in a true function. The true function basically checks if the value is true, then returns that particular result. So let us see how we can use this. In the true, I'm going to go here onto the next line. If the switch statement is true, so I'm going to refer to my column here, which is colored. If my color here is equals to red, close the quotes followed by a comma, then the argument here is the result. What is the result that you want when the color here is red? I'm going to type in a yes here, which is a fast moving color, followed by a comma. As soon as I enter a comma here, you will see that it's asking me to enter value 2. On the next line, I'm going to enter the value 2. I'm going to pass in the color again is equals to, if my color is black, close the quotes followed by a comma, then this needs to be an yes again. I'm going to close the quotes followed by a comma. On the next line, I can pass in another color. I can say color is equals to green, close the quotes followed by a comma, then this needs to be an yes. I can go on and on and on and mention how many ever colors I want using the switch statement followed by a comma. And then I can simply, whenever I do not pass in a column here, it will automatically mean that it is an else statement, right? If it is false, if this condition is not met, what is the false statement? In this case, I'm going to type in a no, close the quote, close the bracket here. We have closed the switch statement now. Click on confirm. And now you can see that we've added a new column. And this time when I select yes here, in the color section, I have black green and red. All three colors are mentioned here. Now in the if statement, when I go back into my if statement, you can see that I can only define either an yes or no as an output, because this is only an if statement which is using an or condition, and returning the capability of an if statement is only to return whether it's an yes or a no. I cannot, if I want to return any other value for black, let's say I want to return it's a black color. For red, I want to return this as a red fast moving color. I cannot have a customized output based on a color when using the if statement. But when you are using a switch statement, something like this, you can have a customized output based on the color. Now let us say that red, black and green are your fast moving colors. Let me change the yes to fast moving. I have now changed all the yes here to fast moving. Now let us say I want to add another color here is equals to maybe blue. Whenever the color here is blue, let's say for example, I want to get the output as very fast moving, close the quotes, followed by a comma, and then click on confirm. And now you can see that I have another category here called very fast moving. When I click on OK, you will see the color here is blue. Now this was not possible using our if statement, because the if statement is restricted to only one kind of a category here, whether it's an yes or a no, whether it's a fast moving or a non-fast moving. Whatever that you enter here will be returned as an output. But when you use the switch statement, you have the flexibility to choose the output for every single color or every single condition that you mention in your switch statement. I hope the difference between the if statement and switch statement is very clear to you, and you will be able to decide when to use a switch statement and when to use an if condition. Now let's head to the next section, which is the text functions. Now the text functions basically, like, you can concatenate values, you can use length function to identify the length of the text, you can extract part of the text, or you can convert your text into your uppercase or lowercase. Let's take a look at an example of these. In my customers table, I have two columns here called first name and last name. Let's say I want to concatenate both of these values into one single column. Let us see how we can do that. I'm going to add a new column and call this as full name is equals to, I can use the concatenate function here, concatenate, and it is giving us two different arguments here, text1 and text2, where you can join two text strings into one string. I can simply pass in my first name followed by a comma and then type in last name, select the column here, close the brackets and confirm. And now you can see that we have our full name available here, but there is a problem with this. I don't have a space between the first name and the last name. And when you take a look at the concatenate option here, when I type in a comma here, I don't really have an option to enter the third string as in concatenation, or if I want to enter a space here, I cannot do that using the concatenate function. So to add a space or to concatenate multiple fields, what you can do is, instead of using the concatenate function, which is less preferred, what you can do is simply refer to the column, in this case the first name, type in ampersand or an and, open double quotes here, give it a space, close the quotes, type in ampersand again, and then type in the last name. And now you can click on confirm, and you can see that we now have concatenated first name, last name, and also added a space as well. And you can add in as many fields as you want here. For example, if you can simply type in and, open quote. If you want to add an underscore, you can do that right from here. Click on confirm. You have added a space as well, you've added an underscore as well, you've concatenated the last name as well. So this is how you'll be able to concatenate multiple fields using DAX. Now let's take a look at the next function here, which is the length function. I'm going to add a new column. Let's call this as length is equals to, there is a function here called length, and within the length function I can pass in the column. In this case, let's say if you want to identify the length of the full name, I can do that, close the bracket here and confirm. And now you have the length of the character that I have in my full name column. Now let's head to the next text function, which is using the left or the right function. Now let's add a new column in my products table here. And in my products table, I want to identify, it looks like the product name here, the first word in the product name is the brand name. I would like to fetch that particular brand name here. So what I will now do is, let me just type in brand underscore name is equals to, I want to extract the lit_var as the word here. So I'm going to use, there are two functions. There is a write function which will extract the characters from the right side of the string, and there is a left function which will extract the characters from the left side of the string. So let us use the left function first. So when I use the left function here, the first argument that I have here is to pass in the text that I have. In this case is the product name. I'm going to pass in the product name here, followed by a comma, and then it's asking you to enter the number of characters that you want to fetch. In this case, it is 1, 2, 3, 4, 5, 6, 7 characters. I can type in 7 here, close the bracket and confirm. And now you will see that I have the brand name available here for first few rows here. Wherever we have crossware, it is getting truncated because the number of characters that we have here is more than what we have defined, which is 7. In this case also it's getting truncated. The adventure works is getting truncated. But in wherever the brand name is lit_var, we are able to extract the 7 characters from the left side of the string. So this is how you extract the characters from a particular string. Now you might have a question, how do I extract the full brand name from that particular cell? We will understand that a little later, but first let's understand how does the left and the right function work. So now that we have looked at the left function, I'm gonna just change this to left brand name. Let me add another column here, and let's call this as right len is equals to, I can now use the right function. Simply refer to the product name field here, close the bracket, refer to the product name field that we have in our table, followed by a comma and the number of characters that you want. Let's say you want 4 characters here, close the brackets and confirm. And now you have 4 characters from the right side of the string appearing in your column. Now the next question that you have is, how do you extract the full brand name whenever the number of characters are differing in every single cell? I might have 7 characters here, I might have 10 characters here. So how do I identify that? So to do that, you will have to club in multiple functions into one. Now this 7 that you see here has to become dynamic to identify the number of characters that you want to extract. So to do that, I can use another function here called find. What is it that you want to find? I want to extract everything until a space is available from the right side of the string. So let's find out the space first. So what I will do is, I'm going to open quotes, give it a space, close quotes, or by a comma. Within text, the argument here is within text. So this is where I will have to type in the product name. I'll have to pass in the product name field, followed by a comma. Start position. The start position here means that where do you want to start looking at for the space? From the very first character that I have, I want to start identifying the space, followed by a comma. If it is not found, what is it that you want? Let's say, for example, if the space is not found, I would like to enter a maximum number here. Let's say 50 characters. I want to extract 50 characters from that particular field. And then let's close the bracket here for the left function and then click on confirm. And now when I take a look at this, I have my left brand name, I have lit_var appearing in full, I have WWI appearing in full, I have adventure as a brand name appearing in full, which earlier was not appearing in full. And you can see that all of these columns, all of these brand names here are now appearing in full name. They're not getting truncated. So this is how you can dynamically extract characters from your text string. Now let us say, for example, you have small case, you have uppercase, you have lowercase, all of that combined in this particular column, but you want to convert all of this into uppercase or lowercase. You can do that. I'm going to add a new column here. Let's call this as uppercase underscore brand is equals to, I can now, there is a function here called upper. I can use that and pass in the text field. In this case, it is left brand name. Close the quotes and confirm. And now you can see that all of our characters have now been converted to uppercase. Likewise, there is a function here called lower. I can give it a name here called lower brand name. It's equals to lower, pass in the lower function and pass in the brand that I have here, which is left brand name, close the quotes, close the brackets and confirm. And now you have all of your brand names appearing in lowercase. There are many other text functions that are available. You can explore them at your pace once you've learned them. Now let's head to the next section, which is understanding the date and time functions. How do you handle your date calculations? There are various functions available for you to take a look at, but let's take a look at some of the basic functions that are available. In the later videos that I will make, I will be talking about the advanced date and time functions as well. So make sure you subscribe to my channel and click on the notification bell so that whenever I post the next video, you will get an update and you will be able to learn all of the advanced DAX functions as well. So let's head into Power BI now. So this time I'm going to create measures. So I'm going to create a new measure and call this as today is equals to. If you want to identify today's date, there is a function called today, and you have to open parenthesis and close parenthesis here, click on commit. And when you bring in the measure into your report view and change this into a card, you will see that this is now displaying today's date. Remember that whenever you use the today function, it will only display the date and not the time. So you will have to change the date format here into date so that this is only returning the date and it is not returning the time for you. But if you, let's say for example, if you want to return both date as well as time, you can use another measure, a different function called now. I'm going to use the function here called now. You can simply open close parenthesis here, click on confirm. And now when you bring in the new measure that you created into a card, you can see that it is now displaying both date and time as well. Now let's say for example, you want to extract the year from the date. All you have to do is let me create another measure. And I'm going to call this as year is equals to, I want to extract the year from today's date. What I can do is simply pass in the today's function. You can pass in the measure that we have created, or you can simply pass in the today function that we used earlier. Close the bracket and click on confirm. And now you can see that when I bring in the year into a card, you will see that we've now extracted year from the date. This is the date that I'm talking about using the today function. In this case, I have extracted the year from the date. Likewise, you can extract month as well. When I create a new measure, let's call this as month is equals to, let's use the month function here. Whenever you use the month function, you will be asked to pass in the date. In this case, let's say for example, I want to pass in the today function again and close the brackets and confirm. And when I bring the month into my card here, you will see that it is now displaying it as 1 because we are in the month of January. Likewise, I can also extract day as well. And let's create a new measure and let's call this as day is equals to, I can pass in the function here called day and then pass in the function today. Let's use the measures now, click on close and confirm. And then when I bring this into a new card, you will see that this is displaying the day, which is 5th of January. So this is how you'll be able to split the year, month and day using the functions within DAX. There are other month functions as well. Let's say for example, you want to identify end of month. I want to identify the end of month date. So what I can do is I can simply type in month here. You will see that these are all the functions that are available. I have end of month, I have EOMONTH, I have month, which we saw earlier. We have next month, and then we have previous month and start of month. Let's take a look at some of these examples. What does end of month mean? When you use the end of month function, the argument here is to pass in the date. When I pass in the end of month function here, it's asking me to enter the date. I have the date column in my table. I will pass in that, close the bracket and confirm. And let me bring in the order date here. And let's change this into a table and change this to order date directly. And let's also change the way this is appearing because I just want to display this as date. And now when I bring in the measure that we created, which is end of month, and when I add this here, you will see that for the dates that we have, for example, 7 Jan 16, it is automatically displaying the end of month, that is 30th of January as the date. And when I scroll down or go to the next month, you will see that for November, it is displaying 30th of November. For December, it is displaying 31st of December. So this is how you can dynamically identify end of month using the function end of month in DAX. Now let's create another measure. There is another function called end of month is equals to, when I type in EOMONTH here, you will see that there is another end of month function. Now this EOMONTH function gives you a little more flexibility to identify the end date. So you can enter the start date here. I can type in, let's say for example, I can type in my today's date. I can pass in today followed by a comma, and then it's asking me to enter another argument here, which is months. When I can define the number of months that I want this to go ahead or backwards. For example, when I type in 3 here, close the bracket and confirm, and let's bring this into a new measure as a card, you will see that from the month of January, I have added 3 months, and it is now displaying the end of April, which is 30th of April. Now that's because I have added 3. It has added from the month of January, it added plus 3, it did 4, which means a month of April, and it is displaying the end of month for that particular date. When I do this -3 and click on confirm, you will see that this is now going backwards, and it is displaying the end of month here, which is 31st of October. Now let's take a look at the next function. When I type in month here, you will see that we took a look at end of month, month. The next month basically returns the next month value, and we have the previous month and we have start of the month. When you use start of the month, let's say when I pass in the calendar date here, close the brackets and confirm, and when you bring in the measure here, you will see that it is now beginning to display the first of every month. Whenever the month here is January, whenever it is 15th of January, you will see that it is now displaying 1st of January. When you scroll down, you will see that in the month of August, 31st of August here, the date that we have, it is displaying the 1st of August. Now this can be used in various calculations based on your time intelligence calculations and all of that. These functions can be used. Now let's take a look at another time intelligence function. In my sales table, I have 2 dates column. One is the order date and the other is the delivery date. Let's say for example, I would like to know how many days does it take for me to deliver a particular product once it is ordered. So I will have to identify the difference between the delivery date and the order date. So let us see how we can do this using DAX. I'm going to add a new column. I'm going to call this as difference is equals to. I'm going to use the DATEDIFF function here. It has 3 different arguments, date 1, date 2, and then the interval. Let's discuss about this. So first of all, I'm going to enter my order date because this is the date that I want to calculate the difference with, and then the delivery date. Order date, delivery date, that is my second argument, followed by a comma. And the third argument here is the interval. The interval basically means that the difference that we are calculating between the delivery date and order date, how do you want the output to be? Do you want the difference in date? Do you want to calculate the difference in hour, minute, etc.? Minute basically will be used whenever you have very short time periods where you have your date time as well, and you're calculating the difference between 2 different date times. Maybe you can use minutes there, again based on your requirements. Or you want to calculate the number of months it has taken from one date to another date, you can do that as well. You can calculate quarter, week, year, etc. In our scenario, let's use day as an example. I'm going to close the bracket here and confirm, and you will see that we are now displaying the difference between the order date and delivery date. It is basically telling us that it took 7 days for the order to get delivered from the date it was ordered. Likewise, if you scroll down here, you have different dates. It has taken 2 dates, 3rd May 18 it was ordered and 5th May it was delivered, and that is the date that we are displaying here. So this is how you will be able to calculate the difference between 2 dates using DAX. Now that we've learned some of the basic aggregation functions, the logical functions, the text functions, as well as some of the date and time functions, let's take a look at the next topic that we have in today's video. Now this is an extremely important topic to understand. The row context versus filter context. What exactly does the row context mean, and what exactly does the filter context mean? I might have explained the basics about the row context when I explained about the calculated column, but let's go a little bit more in detail in understanding the row context and the filter context. The row context basically means that the evaluation of the DAX formula happens row by row. It happens on every single row based on a particular table. It occurs whenever the expression is applied to every row individually. right? We looked at the example here. Whenever we calculated the product in the product table, we calculated all of this here, right? So this calculation is happening row by row, and that is what row context means. The calculations happen at every single row. So when does a row context apply? In what scenarios does the row context apply? It applies whenever you create a new calculated column. Remember that whenever you create a calculated column, always the row context is applied. And the row context is also applied in measures as well. But whenever you create a measure, remember that by default, the filter context is applied and not the row context. And when you want to convert or transition from filter context into row context, you will have to use iterators like SUMX, AVERAGEX, filter, etc. Now these are some of the advanced functions of DAX which we will take a look at in the later part of the videos. But understand that whenever in a measure you use a SUMX function or an AVERAGEX function, which is denoted by this X here, it means that it is an row by row iterator. The context has now changed from filter context into a row context. Now let's take a look at some of the examples. So we took a look at the calculated column. We created a lot of calculated columns here, right? So we looked at all of these. Now these are all your row context. These are all your row context evaluations that have happened when we created a calculated column. Now let us understand the row context when it comes to a measure. And I have my sum of quantity, I have my unit price USD. And when I create a new measure, let's call this as sum total underscore. Now I cannot directly refer to the price column that I have here. You can see that we've discussed this earlier as well. I cannot refer to the price column directly because by default a measure works based on the filter context. Now that you have learned the sum column, you might say that I can do a sum of my total price and I can do sum of my quantity. So let us see if that works. I have my sales price here, sum of sales price. Multiply that with sum of quantity. I can close the bracket, click on confirm. And when I bring this into our table, you will see that it is now multiplying the sum of quantity with the price here. The numbers that you see here might display that as to be correct numbers, but take a look at the total here that you're seeing. This is displaying as 3.4 trillion in sales. Now, what is the actual values that we have in our table? We did create a table, we did create a calculated column earlier here, which is based on row context, which calculated the values here based on the row by row multiplication. I have the total price column here. Let's bring in the total price column into our table and you will see that the numbers are not matching, right? You will also see that the numbers here are not matching. 31 multiplied by 188 is actually 5,843, not 64,000, right? So these numbers are factually incorrect. So how do you calculate this? Using a measure, which will iterate row over row and display the values. So what you can do is create a new measure. Let's call this as total underscore sales underscore measure underscore sum is equals to, I am going to use the function here called SUMX. When I use the SUMX function here, I have to pass in the table first. In this case, I'm passing the table sales here followed by a comma. And now I can pass in the quantity column that I have here, multiply the quantity with the price column, that is the sales price, close the brackets and confirm. And when I bring in the total sales measure here into our table, and now you can see that it is iterating row over row. The SUMX function iterates row over row and performs the calculation, and it is displaying the right values here. The right totals are also being displayed here. So this is how you will be able to change the context of a measure from filter context into a row context by using the SUMX function, which iterates over every single row and performs the calculation and then sums the price for us. So this was about the row context. Now let us understand what does filter context mean. Now filter context refers to a set of filters that is applied to data before an expression is evaluated. Let us say, for example, you want to create a measure and you want to do a sum of your sales value, but for the sales for the year 2024 only. So you can apply that filter before the sum of sales is calculated. It can happen at the visualization level based on slicers or filters or row or column headers. Now we took a look at it earlier as well. Now let me add a new table, bring in the brand name. Let me bring in the total price. Now the filter context that we have applied to this table, if I remove the brand here, you will see that our total price is at 55 million. Let me bring in a brand as a slicer here. You will see that when I select a particular brand here, the sum of my total price is getting changed, or the filter is applied to our total price here based on the slicer selection that I make. Now when I bring in the brand into our table, this will also act as a filter context. When I remove the filters here from the slicer, you will see that the data here, or these values, the total price that is being displayed here is based on the slicer or the filter that is applied into our table. We now have applied a brand as a filter here. When I bring in category as well into our table, you will see that we've now added another level of filter, which is the category, and the amount that you see here is based on the filters that I have applied into my table, which is datum as a brand and cameras and camcorders as my total price. That is the filter that we have applied to our total price field. Now these filters can either be applied through slicers or through filters or through the row or column headers. The row or column headers, this is the row and column headers that I'm talking about. I can change this into a matrix, and you can see that still the filter is now being applied based on the row headers and the column headers in my matrix visual. So that was about the filter context. The example here is the measure example is this sum of sales amount. And if the slicer selects the year 2024, the sum function only calculates sales for the rows where the year is 2024. We looked at this example, right? So let me add the year as an example in a slicer, and let me just display this as a year. And when you select the year 2018, all of this is being filtered only for the year 2018, and that is the filter context that I am talking about, which is being calculated dynamically based on the selection that I make. The measure that I have added here is only working based on the filter selection that I make through these slicers and the filter selection that I have based on the row headers and the column headers in our matrix visual. Now I can also pass in the filter context using the calculate function. I can pass in a filter here. I can use the sum of sales amount and then followed by year 2024, and this will only filter the sales amount for the year 2024. So I hope the row context and filter context is clear for you. Let's head to our next topic, which is context transition in Power BI. The context transition is basically a process of converting your row context into a filter context. I will explain this with an example so that you understand this better. But remember that this happens when you use a calculate function or a calculate table function inside an expression that already has a row context. This basically enables DAX to evaluate your row specific calculations as if they were being filtered at the table level. Now when you use the calculate function, this happens. This also happens with an iterator functions like your sumX or the filter function. Let's take a look at an example. Let's go to my table view here, and let us say that I add a new column. This time I want to add a column. I want to sum the values of my total price. So I will pass in the total price column here, close the bracket and confirm. What is the value that you expect, right? The value that you would expect here is basically, because we are in a table and we are used to looking at row iteration, and we would like to see the value here as 568. 159.99 in this row. When you use the sum function, it basically has summed the entire total price column and is displaying the total values against every single row. And this is not what we are expecting. Because we have a table here, we are seeing the row by row. We would like to see the absolute value or the total price here appearing here in our column as well. So to change the context here from row context into a filter context when I mean it needs to apply filter for every single row. So to do that, what I will do is I will wrap this within a calculate function. And when I close the bracket here and click on confirm, you can see that we have now changed the context from row context into a filter context based on the fields that we have here, and it is now displaying the correct price against the total price. So this is how, using the calculate function, you will be able to change the transition from your row context into filter context. So a quick recap, when does the context transition occur? The context transition occurs when you use the calculate function and when you use the calculate table function. When you use SUMX, AVERAGEX without the calculate function, the context transition does not happen, right? Remember these points. Now let's head to the next section, which is implicit versus explicit measures. In Power BI, measures are essential for calculations, we all know, but there are two ways the measures can be defined: implicit measures and explicit measures. Implicit measures basically are created automatically by Power BI whenever you drag a field into a numeric column into a particular visual. Something like you would have seen in a pivot table as well, right? You would have seen this in pivot table as well. Let's say, for example, I bring in brand and then I want to do a count of brand. I simply bring in the brand into the value section here and I automatically have the count created for me. Likewise, in Power BI as well, you can create these measures automatically. I can bring in category, and then if I want to sum the total price, I can simply bring in the price section here. Now what's happening is that Power BI is automatically calculating the aggregation here, which is sum by default, and there are other aggregations as well that you can choose. So basically what Power BI is doing in the background is it is doing you have something similar in Power BI as well. Let's say, for example, I bring in the brand column and I would like to know the total quantity. If I bring in the total quantity here, Power BI will automatically define the measure for me. It has aggregated the value as sum. And there are other aggregations as well, like average, minimum, maximum, count, distinct count, etc. Now Power BI is doing this automatically for us. Now in the background, Power BI is basically calculating a measure, something like this, the one that we did earlier, sum of quantity, sales quantity. Now this is something Power BI is doing that in the background, but we do not have any control. Let's say, for example, I would like to change this or modify this or apply a filter to this particular quantity. I will not be able to do this whenever there are implicit measures. So these are called implicit measures. They are created automatically whenever you drag a numerical column into a particular visual. It can also be a categorical column that will turn into a count. But if it's a numerical column, you get those aggregations as well. You cannot modify or reuse them directly in other calculations. Now that I have dragged the quantity here, I have sum of quantity. This is the implicit measure created. Now it is there in this particular table. But what if I want to use the same measure that is created in another table? Let's say I have another table here and I would like to use that. Let's say I want to have column chart, right? I can do that. Sorry, I can change this into a column chart. What is happening now is that the sum of quantity is getting calculated once again. I cannot just remove this because the sum of quantity here is not added as a measure in our data model. I cannot use the same measure once again here. If you use the same measure in multiple visuals, it will only get calculated once. So I cannot use the same measure, same implicit measure that is used here, sum of quantity, in this visual as well. I will have to bring in the total quantity once again so that it gets calculated once again, and that result is being displayed here. So the key characteristics: the implicit measures are generated automatically whenever you drag a numerical column into a visual. They are limited to default aggregations like sum, average, min, max, count, etc. The one that we saw earlier as well. You cannot use advanced DAX expressions whenever you're defining an implicit measure, and scope is only limited to the visual that they are created in. Now let's take a look at the explicit measures. Explicit measures are the measures that we saw an example earlier, which are created manually. So this is the explicit measure that we created. We have a lot of control over these measures, the way we define it, the way we apply filters, the way the calculation happens, etc. They can be customized, they can be reused, and they can be referenced in other calculations as well. I can refer to this particular measure that I created, total price measure, in another calculation if I want to use, right? I cannot do that when I'm defining an implicit measure. So the key characteristics of an explicit measure is defined using the DAX formula language, of course. Fully customizable with complex logic. You can add additional filters if you would like to, and it is capable of having more advanced functions. It can be reused across multiple visuals. This is the syntax that we saw earlier as well. This is the measure that is reusable across multiple visuals. Just a quick recap: creation method automatically created by Power BI. That's an implicit measure. An explicit measure is manually created using the DAX language. The custom logic is not possible when it comes to implicit measure, whereas the explicit measure is fully customizable with DAX. Implicit measures cannot be reused. It is limited to just one visual, whereas the explicit measure can be reused across multiple visuals. The aggregation type are limited to just the basic ones like sum, average, count, etc. With explicit measures, you will be able to perform complex calculations along with additional filters, custom logics, etc. The flexibility in the implicit measure is really low, whereas in the explicit measure, it is really high. The implicit measures are not recommended for complex reports. The explicit measures are the ones that have been recommended and preferred for all of your calculations. Now, this also comes in handy, especially when you're giving interviews as well, when the interviewer asks you the difference between implicit measure and explicit measure. I hope I was able to explain the difference between an implicit measure and an explicit measure in a very simple language, in the language that you can understand very easily. With this, we have come to an end of today's tutorial, the beginner's guide to DAX. So let's do a quick recap of what we have learned today. We started off with understanding what is DAX, what you can do with DAX, and we also took a look at the simple DAX formula. We understood the difference between measure versus a calculated column. We then took a look at some of the basic aggregation functions like sum, average, count, count distinct, etc. We took a look at the logical functions, the if function, the switch function, the and or function. We looked at the concatenate function. We looked at knowing the length of the text. We looked at how do we extract parts of the text. We also looked at the case formatting, upper and lower. We also looked at the date and time functions. We understood how to use today, now, year, end of month, etc. We also understood the difference between row context and filter context. And then we also looked at the filter context in detail. And then we looked at the context transition in Power BI, how you can do the context transition from a row context into a filter context. And then we also looked at the difference between implicit and explicit measures. And that wraps up our beginner's guide to DAX. I hope you found this tutorial helpful and you are now more confident with the foundational DAX functions. Remember, practice is key. So dive into Power BI and start experimenting. But we are not stopping here. Our intermediate DAX tutorial is coming up next, where we'll tackle more advanced concepts, unlock powerful insights, and take your DAX skills to next level. Don't forget to like this video, subscribe to the channel, and hit the bell icon so that you don't miss out on what's coming next. Drop any questions or feedback in the comments below. I would love to hear from you. Until then, happy DAXing. See you in the next one.